Hi everybody. So this video we're looking at the history of the atom. So we're looking at all the scientists who contributed to discovering different parts of the atom that's led to our belief today in how atoms work. So lots and lots of scientists made observations and they did experiments, and then they made inferences about what atoms look like. Because remember, we can't see atoms, and even today we still can't see what atoms look like. So the reason we did the activity on inferences is because this is what scientists were doing as they were learning about atoms. They make observations from their experiments, and then they use those observations to try and describe what's going on, which is an inference. Okay, so let's start our story way back in about 400 BC. So in this time, the society of ancient Greece had lots and lots of philosophers and scientists who were starting to think about the world around them. And a few philosophers in ancient Greece, they came up with the idea that all matter must be made up of atoms. They didn't really know what they looked like, what they were, but that's the first time that the idea of atoms, of tiny little particles, was thought of. So we're fast forwarding pretty far ahead now to our first scientist that we're actually going to learn about, and this is John Dalton. So John Dalton was an English scientist, and around 1803 is when he made his big discovery. So his inference was that all materials and matter in the universe is made up of tiny particles, which is pretty much what the ancient Greeks thought of as well. But he also realized that different atoms combine together to make compounds. So in 1803, this is the model of an atom that John Dalton thought of. So all we thought was that atoms are just a solid sphere. So we call it the solid sphere model. So if you look inside any material, any object, it's made up of tiny atoms. And he thought they were just like a solid ball. Alright, let's move ahead to 1869. And the next scientist we have is Dmitri Mendeleev. And he was from Russia. His contribution wasn't about what atoms look like, but he was thinking about elements. So remember, the elements are different types of atoms. So elements are different forms of atoms, and they have different properties. And so Mendeleev, he started looking at all these properties of all the different elements, and he saw that a lot of them have similar properties. And he thought the properties of the elements, they seem to repeat in cycles, which they call periods. So a lot of elements had similar properties, and then a lot of elements that were heavier would have similar properties again. So he started to arrange all the elements in a table or an array, just like in maths. And he called this repeating table the periodic table. So this is the table we all know about today, and it lists all the elements in a repeating fashion. Because you start with number 1 at the top, and then you read across, and then you read down to the next line, and read across. So he realized that elements have lots and lots of repeating properties. So amazingly, he discovered the periodic table before a lot of the elements were actually discovered themselves. So his periodic table had gaps in it where he predicted elements would be, and later on, when scientists discovered those elements, they had pretty much the exact properties that Mendeleev had predicted. Okay, fast forwarding again up to 1896, and we have Marie and Pierre Curie. So these were a husband and wife research team of scientists, and originally they were from Poland, but they moved to France where they did all their work. So their big discovery, the inference they came up with, was that some atoms actually release radiation. And so they called these types of atoms radioactive atoms. So their big discovery was radioactivity. So we've got some radioactive atoms, they release different types of radiation. And we'll learn more about the different types later on. Okay, we're fast forwarding again in time. The next big discovery was made in 1904 by J.J. Thomson. And he was another British scientist. So after his experiments, Thomson came up with this inference that atoms are made up of tiny negatively charged particles called electrons. And the rest of the atom is positively charged. So he's the first one that discovered electrons. And his model is famously called the plum pudding model, because it pretty much looks like a plum pudding. You've got the main body of the atom, which is like the pudding, and electrons he thought were dotted in between it. So they're little packets of negative charge dotted amongst the atom like plums in a plum pudding. So that was his idea in, not 1940, in 1904. All right. Well, the next big discovery was made by Ernest Rutherford, and he was a New Zealander. And he moved to Britain to do all his research. So this was in 1911. He did lots and lots of work, and he got all his PhD students to do a lot of the work for him, but he gets the credit still. So his inference was that actually atoms aren't solid. They're not like a plum pudding, they're actually mostly empty space. And that was a big breakthrough. So he realized that the center of the atom, it's really, really tiny, and it's positively charged, and he called it the nucleus. So Rutherford discovered the nucleus, so his model we call the nuclear model. And this is the classic picture of an atom that you've probably seen before online or in magazines, because you've got the nucleus in the middle, and the electrons fly around the nucleus. So by 1911, we were getting closer to our idea of what atoms look like today. All right, not long after that, we're at 1913. Niels Bohr came up with the next big inference. So Niels Bohr was Danish, from Denmark. So his experiments agreed with Rutherford's that there is a nucleus, but his inference was that the electrons, they don't just fly around randomly, they move around in fixed orbits like planets. And he called these planets shells. And scientists agree that electrons orbit in shells even to this day. So here's Bohr's model. We call it the planetary model because the electron shells look like orbits of planets in the solar system. Alright, so we're still in 1913. The next scientist, he came up with a different idea, not related to what atoms look like, but back to radiation. So this scientist was called Frederick Soddy. He is another English scientist. And he did lots of experiments on radiation, and he realized that when atoms release radiation, they actually become a different element, which is called transmutation. And there are different forms of elements that are called isotopes. Some isotopes are radioactive and some of them aren't. So that was a couple of big breakthroughs that Schrödinger made. So here's an idea of what he discovered. Radioactive isotopes. Some isotopes of carbon are radioactive, and when they release their radiation, they actually change into a completely new element. And in this case, it's nitrogen. Okay, we've got two more big breakthroughs. So we're now in 1926, and Erwin Schrödinger, he's a famous Austrian physicist. You might have heard of Schrödinger's cat, which is an imaginary experiment that he came up with to try and explain his inference. But his inference was that actually electrons are flying around at the speed of light, which is so fast that we can't actually know their position. So it's better to think of electrons as just a cloud, and electrons exist in that cloud somewhere. So the cloud is where the electrons probably exist. We never know exactly where. Because if something's going at the speed of light, it's going so fast, we can't actually know where it is. And this model is the first of our really modern day ideas of atoms, and it's called the quantum model. So you still have the nucleus, there's still protons in the nucleus, and there's still electrons, but instead of having just rings where the electrons fly around, they're in these electron clouds. You can see here there's still a blue cloud and a yellow cloud, so Bohr was right that there are different shells, but the shells are more like a cloud. Okay, and here's the last big breakthrough. So this was in 1932. So scientists have known what atoms look like since about this time. So James Chadwick, he's another English scientist. Lots and lots of English scientists working at this time. So his big breakthrough is he discovered neutrons. He figured out that there aren't just protons in the nucleus, there are these neutral particles. So he actually called them neutrons. So his model, we can call the modern quantum model. It's just like the quantum model, but the nucleus now has neutrons in there too. There's protons and there's neutrons. We still have electron clouds, and we still have shells of electrons. So they are all the big breakthroughs that scientists made, leading us to our modern day view of an atom. Alright, so you should have filled in every scientist now in your timeline of the history of the atom, and you can use this to refer back to in your book.